Okay, this is the first lesson in chapter 6, 6-1, Rational Exponents and Properties of Exponents. So we're going to be working on different types of problems with exponents, basically. So there's a couple practice problems I want to work on with you. How to solve multiplying exponents. So when you have this situation, if we were to do it extended, 3 to the second power would be 3 times 3. 3 to the fourth power would be 3 times 3 times 3 times 3, right? Now, what are you doing with 3 to the second power and 3 to the fourth power? You are multiplying them. So you are multiplying all these 3's together. The shortcut to write it is like this. Three to the second plus 4. You take the exponents, you add them together, and you get 3 to the 6th power. Like that. 3 times 3 times 3 times 3 times 3 times 3. And you get the same answer. So you would just use your calculator and do 3 to the 6th power. Okay? So this is how the shortcut is written. You have that times a different exponent. So what you're going to do is you're going to add your exponents together to get your answer. Okay? All right, now what if you're dividing? What if you're doing this problem? Well, if you do the extended problem here, 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. When you're dividing the same number as your numerator and your denominator, what happens is they cancel out. Now you don't get 0 on the bottom, you get 1. So you're left with 3 times 3, which is 3 to the second power, over 1. The shortcut to do this problem would be 3 numerator exponent minus denominator exponent. 5 minus 3, and you get 3 to the second power. So that is the shortcut. The rule, if you're going to write this down as a rule, it would be like this. Take the numerator minus the denominator exponent, and that'll give you your answer. So it's basically like the opposite of multiplying. Okay. All right. The last example here is, what if you have a number with an exponent and you have another exponent there? Well, what this would mean is you have 3 sets of this parentheses, like this. 3 to the 4th, 3 to the 4th, 3 to the 4th. That first 3 doesn't even look like a 3. Okay, and you are multiplying all these together. Well, if you remember the expansion rule up here, you have 3 times 3 times 3 times 3 in each of those parentheses. So 3 times 3 times 3 times 3 times 3 times 3 times 3. Basically, you have a bunch of 3's multiplying. How many 3's would that make? How did I do that? Because if you add up all the 3's that you're multiplying, you would get 12 of them. There would be 12 3's multiplying here. And I don't want to do that because it takes a long time. So I want to show you the shortcut. The shortcut is you take the exponent on the outside and you multiply it to the exponents on the inside. And you would get 3 to the 12th power. So the rule for this one, you have the exponent on the outside. You want to just multiply those exponents. Now you notice I use 3 on all of them because these only work when the base, the big number, is the same. So if you're going to multiply 2 exponents like this, they have to have the same base. If you're going to divide 2 exponents like this, they have to have the same base. And here, because it's the same set of parentheses, they all have the same number as the base. Okay? So that's the first set of rules. Now, we're going to switch it up a little bit. What if you have fractions in your exponents? Let's talk about that. Now, if you have a fraction, what you're going to do is a little different because there's two exponents here really. There's a number on top and a number on bottom, okay? So the rule for this is the number on the top would be considered your regular exponent. It would be 3 to the second power. What about the fraction? Well, the fraction can be treated as a separate thing. What the fraction is, it acts like a root. Like most of you guys will be familiar with a square root. In this case, this would be a fourth root. So it would look something like this. The square root, but with the number 4 in front. And inside would be 3 squared. Okay, so what is this doing? This is basically anytime you have a fraction, a denominator, in your exponent, it becomes a root. You can simplify this. So for example, here, if you simplified this, because it is a fraction, you can say that is 3 1/2. Okay, so how do you do this? Well, your top number is a power of 1. So you can just not worry about that and deal with the exponent. That would mean you're dealing with a square root. Because really, if it's a power of 1, you could write it there, but it doesn't do anything. So the way you would write your answer is just the square root of 3. Yeah, normally the square root implies a power of 2. We don't really ever write the power of 2. If it's bigger than 2, like a 4, you would write the 4 on the root. Here's another example. 8 to the cube root. So again, there's no number on top, so you don't worry about that. But your root has a power of 3, so we call that a cube root. And there's an 8 inside, like that. Now, normally this would be fine, except a cube root is actually asking you what number multiplied 3 times would give you 8. So what number would give you 8? This actually does have an answer. There is a number that if you multiply it 3 times gives you 8. The answer is 2. Because 2 times 2 times 2 would give you 8. And that's how a cube root works. The last example I want to show you is what happens if you go negative. So let me write one down real fast. Let's do this. I'm going to go back to the examples of 3. Let's say you have this, okay? This is not a fraction like the other ones were. This is going to give me something different. We'll show you. 3 times 3 times 3, 3 times 3 times 3 times 3 times 3. Now, what you're going to notice here is those cancel out. You leave a 1 on top, but you have 3 times 3, which is 3 squared, on the bottom. Okay. The shortcut for this was the subtracting one. 3 minus 5. 3 minus 5 would be 3 to the negative 2. Now, this is where it's a little strange. Right here, you have a negative exponent. But if you look at the way you did it with the expansion, when you do all the 3's, all that negative means is that the negative is on the bottom of a fraction. So whenever you see a negative exponent, you're going to write a fraction and move that to the bottom. And when you move it, it becomes positive. All right, but if I move that to the bottom, what do I write down on top? Well, you can just write a 1 in there. And we have the same answer. So the shortcut works like this, the expansion works like that. And if you did go a step further, it would be 1 over 9, because 3 times 3 is 9. Okay, and that's the basic rules of exponents with negatives, with fractions, and previously with positive exponents. Okay? So we're going to stop right there. with the rules of exponents.